Right. Good afternoon, everyone, and thanks for joining us for this discussion panel around the future of electric grid and data centers. My name is Samira Nikzadgharab. I'm from CBRE, project director, and I will be moderating the panel. And I've got the pleasure of having Ciarán Forde from Eaton, Joan Collell from Flexidao, and Michel Chatelin from Sutherland, Eversheds, Sutherland. Speaking about data centers and electric grid, obviously the power generation industry is going through dramatic change, as we all know. And this is due to increasing demand for the data centers globally and also increasing of demand for the power. And also, we are all witnessing a lot of factors around political issues and environmental issues that are in Europe at the moment and in the whole world that are driving both energy and decarbonization. So, Michel, the first question that I wanted to ask is, what are the most important drivers of these recent development and changes? And what are their impacts? And what are we expecting in the next few years?
Yes, thank you, Samira. Good afternoon, everybody. It's good to see that there are a bit more people now with this important topic of grid connection than in the earlier session, because I think it should be really on top of mind of everyone. Before I get into your question, I want to take the opportunity, because I cannot resist in sharing this with you. If you look at this, the question of this session is called Data Centers and the Electric Grid, What's Next? I think the elephant in the room is what's happening at the moment in Ukraine and the impact that has on our energy supply. I just got in my mailbox the Dutch approach how to deal with electricity crises. And I don't want to create any panic, but I think also what I see, what our customers in the data center sector are worried about, is that we should have attention and be concerned about the security supply of the sector, particularly with regard to electricity and all kinds of things in place. So forgive me for making this comment up front. We can talk about that a bit later on if you want. Back to your question, if I put it in the context of what is on top of mind of the C-suite people that had the session this morning, I think there are two or three things. One is pricing of electricity. The second one is, let's say, sustainability and everything that goes with it. If you then look what regulation does in those fields, because that's what your question was about, I think regulation in Europe, of course, takes place on different levels. We call that dynamic regulation. So you have a combination of mandatory rules that are being designed on European level or on national level, and then also there are non-binding rules that are being agreed on the sector level. So what's driving the data center sector? I think, first of all, the Green Deal that was concluded with the sector, which basically is a drive to energy efficiency and decarbonization of the data centers. I think everybody is aware of it, everybody is working on it, but the goal is to achieve zero emission, so there's a long road to go. It is regulated in terms in headlines with main targets, but then it becomes very specific on national levels. Everybody from the Netherlands knows the actual discussion about energy saving measures and how to implement that and who is responsible for what, data center operators or the tenants within the data centers. So that certainly is a strong drive. And then on the sustainability field, we have requirements with regard to design of components of data centers that will be regulated even more. But then I think the other topic, which is more in line with what we discussed today, is how to manage our grid and what's the position of a data center vis-à-vis the electric grid. As people may know, is that a data center at the moment does not have a specific status within the electricity regulation is just a large off-taker, not a producer yet of electricity, and the rules apply like to any other off-taker. So generally speaking, you have different rules for very large off-takers, let's say about 10 MVA and below, which means that if you are very large, if you have a very large connection, that you can connect to the high voltage grid instead of to lower distribution grids and everything that goes with it. But there's not a special status yet for data centers, and I flag that because if you take into account the public debate and pressure that is on the data center sector, you have to change the narrative in your advantage in a way that you explain to people what positive role a data center can have in our electricity grids and electricity networks. So basically that's a call to consider to fight for a special position, but also, and that's getting back to my first point, answer the question or raise the question whether data centers should be qualified as critical infrastructure, and what does that mean? Does that mean you have additional responsibilities within that grid, being it serving, playing your part in security supply or as a backup, or anything related to that? I think we're going to pause for the moment because otherwise I'll take up all the time here.
That's fine, sure.
Thank you.
I'm just going to move into Ciarán, and I'd like to ask you about the solutions that are possible at the moment to cope with these changes and developments.
Thanks, Samira. Well, it seems an almost impossible task. That on one hand, we're seeing the electrification of multiple industries, transport, heating, cooling, and at the same time, a digital growth. So the appetite for energy, electrical energy, is soaring. And at the same time, we're trying to decarbonize electricity and go green. So it seems an impossible predicament that we find ourselves in. We also, as data center stakeholders, realize that the data centers become somewhat of a political football. In the absence of intelligent, coherent energy renewable plans executed in the last 30 years, a lot of energy generation companies and transmission companies are pointing to the consumption of data centers as if that was the problem. And of course, that's not the problem. It's the fact that we haven't provided enough green energy to support our economic growth. So the data center is finding itself in this difficult position. We heard from the first panel today on how we need to change the narrative. In simple terms, we have to, as an industry, be part of the solution, not the problem. And that sounds cliche, but there are technologies and there are methods that will allow us to actually do that. We're in the middle of what is generally known in the energy world as the energy transition, as we shift from fossil-based fuels generating our electricity to renewable, sustainable methods to create that electricity. It has been well understood the nature of that grid system means a completely re-engineered grid. You cannot operate the traditional production, consumption, linear model. You need to move to a circular model where consumers are also producers. And you have a bidirectional energy management system, an intelligent grid system that can manage all the disaggregated points of consumption and production. Because what's missing in the renewable energy fabric is system inertia. When you remove fossil fuels, you lose that rotational mass that provides inertia to keep us at the critical 50 hertz level on the grid. So when you remove that fossil-based rotational mass and you substitute it with wind or solar, you lose that inertia. So the grid ultimately will become a different beast that needs to be managed in a different way. It's more vulnerable. It's more susceptible to frequency changes. So you'll see that task of managing a new grid system, which is fundamental to the adoption of renewable energy, will need additional services from prosumers. And this is where the data center industry can elegantly step in, because we have up to 9 to 14 gigawatts of latent power in our backup storage systems. Ideal and ready to be made available back to the grid as grid services without compromising the operation of the data center at all. So the UPS and battery storage systems, the on-site generation that is used from backup, will start to change. And I think either by advanced thinking data center operators, which there are 5 data centers I can mention to you that are operating in this way, giving these grid services back, or they will be compelled at national or EU level to do so. We heard again on the first panel, how regulation is coming. It's just a question of when and how constraining it'll be. So as an industry, I think it's very important for us to get ahead of that, use our digital infrastructure, our electrical infrastructure, to provide those services back to the grid to enable the decarbonization of electricity, accelerate the adoption of renewable energy, and then the data center can really, truly wave a green flag of sustainability and say, hey, we've helped bring about the early adoption of renewable energy, and not be blackened as the consumers that we are, the heavy consumers. And again, I think a lot of people often make the mistake of not seeing data centers as the most electrically efficient infrastructure there is. Far superior to any other industry, far superior to telecommunications, far superior to disaggregated or enterprise compute. So we're already the most efficient environment. But if we can use that infrastructure to help the grid operators accelerate their energy mix up to 60, 70, 80% of renewables, we will have been able to position the data center as a real part of the solution, not this demonized part of the problem.
Thank you. So, Michel, this bidirectional grid and the concept of it, I think is going to open a whole host of legislation and contractual and regulatory issues. Is there any thoughts on that?
Yes, many thoughts. Well, I don't want to overcomplicate things, but it's true that it needs to be enabled. So there's a regulation element to it. That the electricity grids are natural monopolies, so that's a justification for the EU and national regulators to regulate it, so that you have fair, let's say, access to it and that they don't exploit their users. So I think the main concern for grid operators is to legislate in a way or create rules in a way that to make distinction between the different entities are connected. So if we talk about a special position for data centers because the narrative that was just explained will justify to have such role, it needs to be enabled. For that, national codes or preferably European electricity codes need to be designed. Then in contracting terms, because that was the second question you asked, I think there are 2 elements to it. One of course, are the contracts that you enter into with the grid operators, so your connection and your transport agreements, but also those agreements that should enable to offer flexibility services, I want to call it, because first of all, that needs to be enabled by the grid operators, but then you need to contract it and to agree what role you will have in it and what money flows go with that. And then I think on the second layer is that the tenants or the users of the data centers will also have to play their role in order to make it all work. And so you also would have to contract that in order to make sure that it all happens.
Thank you. Joan, we touched briefly on decarbonization, and the question is, the adoption of green energy is well publicized by a lot of data center operators, but how is it really achieved? Is it something that can be measured? How is it being measured? And also, how can the data center operators make sure that the renewable energy that they're using is carbon-free?
Thanks. I think first, to answer that question, we need to explain how renewable energy consumption actually works. So when a data center or any company says that they're consuming renewable power, how can they measure that? Well, the power obviously gets injected into the grids, and the moment it does, there's no green electrons or brown electrons. By physical definition, they all get mixed. So the way or the instrument that is recognized officially by the Greenhouse Gas Protocol to claim that your power is renewable is an instrument called the Guarantees of Origin in Europe, or the REC system in the US. And they are financial instruments that represent that a certain volume of renewable power has been injected into the grid, and it's the equivalent of your electricity consumption. Now, the big misunderstanding is that these guarantees of origin do not really reflect the CO2 content of that power. Why is that? Well, because sometimes you're consuming power when there's no wind or when there's no sun. So as a consumer, you don't really know where your electricity comes from. You don't really know when it was injected into the grid. And for this reason, there's a big trend now in the data center industry called 24/7 carbon-free electricity sourcing. You probably heard of it from players like Google or Microsoft that have established a 24/7 carbon-free energy target by 2030. But also colocation data centers are following. Companies like Iron Mountain have a target by 2040. And what they're really trying to achieve is to give price signals that can help energy suppliers invest in technologies that can help cover the gaps of power consumption in which there's no renewable energy. So data center operators are using that as a means for CO2 transparency to share to their customers the real CO2 footprint they have. To avoid misunderstandings, it's important to clarify that there's two different types of CO2 calculations that can be done from the electricity sourcing. One is coming from the grid in which you operate in. And as a consumer, you have no way of affecting that because you're simply present in a grid mix. And that type of CO2 is called location-based emissions. Most companies do it on an annual basis, but it can also be done on an hourly basis to be much more accurate because the grid is volatile. And the second type of CO2 emissions that data centers and companies have to calculate is called market-based emissions. So these are the emissions that come from your contractual renewable energy. So these are the emissions that come from the guarantees of origin that you're purchasing from. Data centers have an opportunity to shift from being seen as the bad guys to being seen as the energy transition heroes. And hyperscalers are already doing that, and they're putting more and more pressure to colocation data centers to move in that same direction. So how you start in that journey is by really monitoring what's your point of departure, right? So how synchronous you are currently to renewable energy sources. Every company has a certain level of time matching. You just probably don't know about it. So to do that, there's different ways, but we as Flexidao, for instance, we have ways to plug it into renewable energy plants and then match that renewable energy production to consumption so that any data center can see what is their point of departure. And then from there, you can engage in discussions with energy suppliers to try to close PPAs or buy certificates that cover your hourly gaps, to cover the moments in which there's no wind or no sun blowing.
Thank you. I can see that you have already touched on the next question about the data center, the leaders, basically, of this kind of environmental movement. Is there anything you want to add in terms of the environmental best practices that are now being kind of practiced?
I think there's maybe a practical example. I think that might help clarify. So Microsoft has a data center in Amsterdam that we are currently monitoring and certifying on an hour-to-hour basis. And the way it works is that they have a PPA signed, a power purchase agreement signed with Eneco. It's an offshore wind farm. And we're connecting to that offshore wind farm and essentially creating hourly certificates. It's basically a timestamp to the guarantee of origin. So it doesn't replace the current regulatory mechanisms, but it just adds more transparency to it. And then with that timestamp certificate, we are transferring those certificates to the consumption of the data center. And then Microsoft gets kind of dashboards to visualize where are the hourly gaps. And with that, they're engaging in conversations with their suppliers to see what kind of new PPAs or certificates or storage solutions can help them bridge the gap, can help them reach the 24/7 carbon-free energy goal that they're wishing to achieve. And this is something they use also for CO2 accounting, so to get more CO2 transparency to their customers. And it's something that also benefits them economically because we talked before about pricing. When you hedge, when you match your consumption with renewables, you're basically accessing cheaper PPAs. So if you also want to consider the economic variable, not only the CO2 impact, it's also very important to match renewables and consumption.
Thank you. Thank you. Michel, would you like to touch base on your initial conversation around fuel delivery safety?
Yes, sure. I also want to get back to what you just said. I mean, it's absolutely true that taking into account the huge energy demand. I mean, what struck me this morning, if you have the first presentation about where the sector goes to, it's only about megawatts. It's about megawatts. It's an energy consuming industry. So I don't know whether that's the right narrative, but for the wider public, I mean, if you hear numbers like total energy consumption of data center sector is already 2% of the total, which may increase to over 10% within the EU, you have to change that narrative in order to make that happen. And one of the things is, of course, instead of concluding the power purchase agreements, which is done now, and then in combination with green certificates in order to greenify, let's say, the energy, is to get much more active, which is already happening by the hyperscalers as well, into corporate PPAs. So a corporate PPA is basically a very long-term PPA, which commitment to pay the monies under the PPA enables a developer of a renewable energy installation, wind or solar, for instance, to finance it. So then you have a direct relationship between your corporate PPA as a data center and the development of a certain renewable energy asset. So I think that's quite important. Another point in terms of pricing, I think it's good to realize that if you look at what the development is within Europe, is CO2 taxation. So CO2 taxation will depend very much on the energy mix of a given member state. And there you have huge differences of member states relying completely on renewable energy and one or almost completely renewable energy, and other member states, particularly in the eastern part of Europe, relying on fossil industry. So the CO2 tax impact for data centers, being large consumers, can also differ a lot. And then your first part was about the...
If you wish.
Yeah. For the security of supply, I think I made that point already. I think it's very important. Of course, we cannot just from overnight make sure that you get independent from the grid. But I think to have contingency plans in place which go further than only very short interruptions in energy supply with the backups that are already built there, to take into account how to deal with larger interruptions in any given member state, particularly the countries that are largely dependent on gas. All the electricity production is dependent on gas, are, I think, at the moment extremely vulnerable. So that's something I think I would really advise to get a grip on what it means for each individual.
Yeah, sure. That's something to definitely think about further. Is
If
there
I may-
anything you'd like to add?
Yeah,
Please.
I think it's very assuring that Joan explained there's some technologies out there that can give a very true representation of renewable energy consumption at a data center. But even if you had a data center that said, oh, I'm a green data center, I still don't think it's enough. If you have tactically secured certificates of origin and you've been able to prove that 98% of your personal energy consumption for your personal data center is green, well, good for you. But what about the full decarbonization of energy across the entirety of the grid system? What are we doing for the overall environment, for society at large? It's nice that your data center is green and you can market yourself as green, but what has the industry done for the overall decarbonization? Because not one certificate of origin displaces carbon-based electrical generation. It's still being produced. So if we want to be sincere about the decarbonization of electricity, it's the data center industry that says, well, we want to do more than that. We want to decarbonize electricity for all, outside of the four walls of the data center. And you can do that through providing grid services back to the transmission system operator, so that they, on a grid level, can onboard more and more renewables. And then you're an active participant, a good grid citizen, decarbonizing energy for all, not just for your own data center.
That's when the interaction with grid will play
Absolutely.
a big part, isn't
That
it?
becomes the grid interactive data center. And the innovative operators will get there first. But as you can see in the European Energy Efficiency Directive, they have singled out our industry. Not industry, not transport, not domestic fuel use, but the data center industry has been singled out for transparency on sustainability indicators. So be assured it's coming. And wouldn't it be better if, as an industry, we preempted that and showed how shifting your backup power system to be a truly on-site generation solution, whether it's natural gas, for example, and being able to use dispatchable power from your own facility back to the grid in times of need, or simply through fast frequency response where the data center just goes on battery for 4 to 5 seconds, has an incredible stabilizing effect on the management of the grid. And of course, the other benefit is those services carry a very, very generous remuneration. So it's an additional revenue stream, and you're helping decarbonize energy at the grid level. And that's the concept of a grid interactive data center.
Thank you. I'm really aware that this time slot will not be enough for the discussions in depth. So please, if you wish, please reach out to these panelists and make sure that you get the information you need. We have got about 3 minutes for QA or any other thoughts. Shall we go for questions, guys? Is there any questions? Great, let's go home. Oh, there you go.
Just a quick, do you think with all the recent developments, having a data center plugged into a lignite power plant next to a coal mine is actually an attractive proposition in terms of energy security versus the green things that we all cared about until today? Is there any kind of shift or room for energy security which becomes more important than decarbonization?
Well, the example you give, a data center located next to a I'm going to use an example because there's a complexity to that, talking about a grid. Because if there is a blackout, so to say, those are always regional blackouts. So parts of the grid are being shut off. So and within that part of the grid, you cannot make a distinction between the individual connected entities. In principle, that's a technical challenge. But if you would be directly connected to a coal-fired electricity generator without the grid, that would be a big advantage actually for that situation. But I think generally speaking, any future solutions where you have on-site electricity production, regardless of what the source is of it, puts you, of course, in a more beneficial position if you talk about the possibility to operate standalone.
I'd be tempted to still stick with the plan to go green, go as fast as we can, and the recent crisis that we see, our dependency on natural gas and suppliers of that is not at a desirable situation. So going green, going fast, using all the plans that are available there, solar, and personally, my background in physics, I still am a nuclear guy, so I see nuclear safe as a part of the energy mix. Safe nuclear, solar, and wind would allow us to keep away from the fossil-based fuels. We wouldn't necessarily need to backtrack on that strategy, I believe.
Thank you. Any more? Joan, would you like to add anything?
No, maybe just to add a small point, building on what Ciarán said before, if you also do load shifting, then you can match better consumption and production of renewables at a local level. That enables not only the CO2 topic that we were discussing before, but it also enables energy security because you're basically avoiding congestions at a local level. So that's another incentive for these players to start thinking of how am I matching to renewables at a local level. Am I being an active grid player, or am I being a responsive consumer?
Thank you. Any? I've got. Well, maybe we should stop the questions. It's this 5 minutes break there between the sessions. I'm sure you guys will join me thanking Ciarán, Joan, and Michel for all the illuminating insight during this panel, and thank you very much for all being here. Have a good rest of the day.
Thank you.